Guys, let us look at example number 7. Here on the left hand side, I have a combination of tangent function and the secant function. Guys, the other thing that we can note here is that it's the quadratic form. We have already seen an example where we have quadratic form and then we use the method of factoring, or one can also use the quadratic formula to solve for a particular variable. Guys, in this case, since we have on the left hand side, we have two different variables, namely tangent and secant, so we cannot factor or we cannot use quadratic formula right away. So what one needs to do before trying to do factoring or quadratic formula, one needs to actually transform this with the same with the same trig function, whether tangent or secant or some other function. But guys, if we want to try and do that, we have to remind ourselves a relationship between the tangent and secant, and there is a simple relationship that relates the tangent with the secant. Guys, if you remember it, that is great. If not, then we have to go back to the formula sheet, the trig formula sheet, and you can find it like in the probably the first or the second, or like it is going to be in one of the like first few formulas or first few rules. So guys, I'm going to write that down and then we're going to use it. It's a very simple relationship which says that tangent square theta is equal to secant square theta minus 1. It may not be written like this in your formula sheet, or I don't know, maybe you are using one where it is written exactly like this. Guys, sometimes it is also written as 1 plus tan square theta equals to secant square theta. So if it is written like this in your formula sheet, then guys, what I basically did here was I just isolated the tangent square theta. Why did I do it? Because I want to replace this tangent square theta or rewrite this in terms of the secant so that we have everything in terms of the secant on the left hand side. So from this formula right here, I'm going to replace tangent square theta by secant square theta minus 1. So I'm replacing this by secant square theta minus 1, and then I just bring in the, sorry, I don't have to use theta here because it's x, so I have to be consistent with what the value or what the angle is, x there. So then there's a secant x, just got to rewrite that, and minus 1. Guys, we can clearly see that this negative 1 and negative 1, we can just combine those two numbers and we'll get, so I should also put implies, then this implies that secant square x plus secant x minus 2 equal to 0. Now the left hand side is in the quadratic form. We can see that clearly because of that square. There are three terms. It's a trinomial, and everything is in terms of the secant, and of course we have that constant. So guys, this we can compare to the standard form ax square plus bx plus c. And when we have it in the standard form, or when we have a quadratic function in the standard form and we are trying to solve for a variable, guys, the first method that we should try to use is the method of factoring. If that works, then we will use it to find the missing variable. If that does not work, then one should try using quadratic formula or other methods. Here, let us try and see if we can use the factoring method, if factoring method actually works. So guys, for factoring method, we start with actually just drawing those two parentheses, and then here obviously we're going to get a secant x and secant x. We already know that because secant times secant is going to give me back secant square x, so that is already taken care of. And guys, keep in mind there's an invisible 1 here. Now we want to come up with two factors of negative 2 so that they add up to positive 1, and I think we can come up with, what about 2 and negative 1? Well, 2 times negative 1 is negative 2, and 2 plus negative 1 is positive 1. So we are able to write the factors here. So I can write plus 2 here and minus 1 here. So those are the two factors. You got to set them equal to 0. And now from here, I'm going to use the zero product property, which basically tells me to set each one of them equal to 0. I'm going to set secant x plus 2 equal to 0. If I set it equal to 0, secant x would be negative 2. I think I can skip that step. And then for this one, for the second piece, this secant x would be equal to 1. Guys, let us focus on this box now. We have secant x isolated and we have solved for secant x, but keep in mind our goal is to solve for x, and it is restricted between 0 and 2 pi. Now guys, from here we like to look at the unit circle and try to identify the value for the angle here, the value for x. But we know on the unit circle we don't have the secant, right? Secant is not directly provided to us on the unit circle. Rather, what is provided on the unit circle is the reciprocal of secant, which is the cosine. So from here, guys, the first thing we would like to do is we would like to write the value for the cosine, because then it's going to be easier for us to actually just directly look at the unit circle and fill in the values for the x. Okay, so cosine x will be, since it's the reciprocal of the secant, so it would be just 1 over -2, which is -1/2, right? Or same thing we are going to do here. Cosine is the reciprocal, but reciprocal of 1 is just 1, so it's not going to change in this case. Now, this is the box, like, which is the most important box for now. From here, we were able to get the cosine, and now we can look into the into our unit circle and find the values for x. Guys, cosine x is negative here, so cosine x is negative in the second quadrant and in the third quadrant. So for this value, we only have to look in the second and the third. Cosine x is positive in the first quadrant, and it is positive again in the fourth quadrant. So for this, we have to look in the first and the fourth. So let us start with this. For cosine x -1/2, looking at the right quadrants, what do I get? I get x equals to, I'm going to write those values here. So for this one, I get 2 pi over 3, and then I get also 4 pi over 3 because I want the answers in radians. So that's why I'm using 2 pi's here. And keep in mind, it is negative in the second quadrant and in the third quadrant. And this guy is in the second quadrant, and this guy is in the third quadrant. Okay, so that also satisfies those conditions. Then the third one, or we'll see for what do we have for cosine x is 1. So for x1, what do I get? I only get one value, which is x equal to 0. Okay, that is the only value. I want to make sure, again, checking my unit circle, and guys, you should have a unit circle handy. Keep in mind, the cosine is the x value on the unit circle and sine is the y value. And for 1, there's only one value between 0 and 2 pi, that is just 0. Okay, so guys, that is how we are going to solve this this example where we have different functions on the left hand side. So by using an identity that relates these, we're able to just have one function on the left hand side, and then we use the factoring method. Finally, we also had to use the unit circle. Guys, these two, this value and these two are the solutions. Okay, that's example 7. I will see you next time with example